In number 2 from an AP test, let's see what they say. If y equals 2x minus 8, what is the minimum value of the product xy? So they're not giving us a shape, a situation. They're describing a relationship between numbers. So the minimum value, so I know I'm looking for a minimum, and it's the value of the product xy. So I know that I'm minimizing a product. I'm going to call it P for product, just so I know how I'm setting this up. X times y, the minimum of x times y. Now again, I have two variables, and if I want to take critical numbers, I don't want two variables. But this time, they already gave me a relationship between x and y, so I don't have to think too much about what it is. I just have to use it. So I'm going to plug that in and get x times 2x minus 8. And again, let's simplify this. 2x squared minus 8x. Now, if you just look at this function, you know this is a parabola opening up, so you know that there has to be a minimum value. Let's figure out where that is by finding the derivative to get the critical numbers. 4x minus 8, let's set this equal to 0. And it looks like it's at x equals 2. Now, like we said, we know this is a parabola opening up, so we know there has to be a minimum value and just a minimum value. But let's practice using the second derivative test just to check. P double prime, derivative of this is 4, and the second derivative is a positive value all the time. Therefore, we know that P is concave up, looking like this. Therefore, yes, it is a minimum. Well, we knew that because this is a parabola, but this is the kind of thing you're going to do to test. So we know it's a relative minimum, which is what we were looking for, a minimum. Now, what is it that we want the minimum of? What is the minimum value of the product? So this time, it's not the x and the y we want, it's the minimum value of the product. So here's an equation for product, but that's in terms of x and y. If I only know x, I want to use the equation of product that only has x in it. So using this, the product is 2 times the x value minus 8. So it looks like 4 minus 8, negative 4. So negative 8. There's my minimum value of the product. Let's look at one more situational problem together. Number 3, a box with a square base and no top is to hold 32 cubic inches. Find the dimensions that require the least building material. A box with a square base and no top. So let's try to draw this box. Okay, so there's my three-dimensional box, and if we want to, we can show what's behind these. So there's the edges behind. So the box has a square base, so the base, the length and width are the same. And no top holds, find the dimensions required the least. Well, there's a word that means minimum, the least building material. So what I'm using to build it. So it doesn't say anything about the height, which means I can't assume the height is the same. So I'm going to have to give the height another variable. So we'll call the height y. So the length and width are x and the height is y. It says it's holding 32 cubic inches. Cubic units is a measurement of volume. So I know the volume of this box is 32, and how do I find the volume of a rectangular prism? Length times width times height. So the volume being length times width times height, well, actually I'm going to use the variables that we did in our picture. Length times width times height is 32. So x squared times y is 32. There's a relationship between x and y that can help me find the minimum building material. So what does that mean, the building material? The building material, what I use to build it, so this surface put together with the back surface, with the front surface, with the side surface, with the bottom surface, these are the surface areas, the areas of each surface. So now remember that there's no top in this box. So let's think about all the surfaces. So the bottom, it's a square, x times x, or x squared. The side is a rectangle, maybe a square, but the most I can say is that it's rectangular, so x times y. But there's a left side that's the same as the right side. And there's a front that's also x times y and a back that's also x times y. So the two sides, the front and the back, are all x times y. So all of those together make 4 xy's. Two sides, a front and a back, 4 xy's. So put these together and the building material or the surface areas, I'll call it A for area, is the bottom put together with the 4 sides, front, back, left, right. So this is my equation that I'm trying to find a minimum for, the least of that. Now again, x's and y's mixed up, I don't want them mixed up. So let's use this to help us. We can solve for y because it's easier, 3x 32 over x squared. Plug that into area. So let's rewrite our area in terms of just x. X squared plus 4 times x times 32 over x squared. And we know that we're trying to find the derivative to maximize. So let's simplify this so that the derivative is easier. X squared plus 4 times 32, 128, x over x squared, or x to the negative 1. Now do the derivative. A prime is 2x. Not going to be plus because of the negative 128, x to the negative 2, or 128 over x squared. Now, where the derivative doesn't exist is where x is 0. So remember, for finding critical numbers, where a prime doesn't exist is where x equals 0, because the denominator is 0. Where a prime equals 0 is where 2x minus 128 over x squared equals 0. And if we solve this, we can do that, multiply by x squared and divide by 2, and we get x cubed equals 64, so x equals 4. So we have two critical numbers. However, does it make sense to say x equals 0, the length of the box and the width of the box equals 0? No, it doesn't. So we're not going to use that number. That means that x equals 4 has to be the value where we have a minimum. But are we sure that it's a minimum? Let's test. Let's use the second derivative. So here's our first derivative. Let's go from there. A double prime is 2. Negative 2 over here, that's going to make 256, so plus 256 over, and that's going to become x cubed. Now this time there's still an x in there, so I don't know if it's positive or negative, but if I plug in my 4, if I do a double prime with 4 plugged in, that's going to be positive. So the second derivative will be positive, which means a is concave up, and concave up does give me a relative minimum. So according to the test, at x equals 4 is where I have a relative minimum. Now what exactly am I trying to find? Let's reread. Find the dimensions. The dimensions is the length, width, and the height. So now I know that x equals 4 is where I have a minimum. Let's go back and make sure that we say the length, the width, and the height. So the length and width are both x, so 4 inches by 4 inches. And what's the height? Well, if I have y in terms of x, y equals 32 over 4 squared, or 16, that means y is 2, so by 2 inches. There's our dimensions.